Okay, welcome back. Been having a bit of a discussion online, and Greg from the Hamandshortwaveradio channel has suggested that I check the logic on the PLL chip. So really, it's something strange. We'll get to that in a minute, but anyway. What I'll do is I'll go through the bands one at a time and just check off that it's correct. So basically there's 2, 4, 6 pins on this chip, which are the outputs. No, they're the inputs to the chip. Sorry, yeah, they're the inputs. So pin 13 to 18 are the inputs from the preceding chip, which is this one over here, and the diodes out from the band switch. So basically we've got the band switch, diodes, we've got this other IC here, which I believe converts it to a level that this other IC can see. And then this is what this is the main PLL chip that generates all the frequencies, or switches all the frequencies. I'm not sure, but anyway. So we'll check band 1 first. So pin 15 should be high, all the others should be low. So start at pin 13, low, 14, low. Hopefully you can see this. Let's just pop that up a little bit. Get you a little bit closer so you can see what I'm up to. It's difficult to show you in here, to be honest. Let me see if I can readjust the camera a minute. Okay, so back with me. Hopefully you can see now. So I'm hooked up. This is powered from the circuit under test, this probe. Basically it's just got a red light for high, green light for low. So it's a nice easy visual way of checking the logic. I could do it with a multimeter, but in case I keep going away, this is a much quicker method. So let's go in then. We'll start with pin 13, just low, 14, low, 15 is high, which is correct, 16 low, 17 low, 18 low. So band 1 logic is fine. Band 2, so pin 1 is high, which is correct. Sorry, pin 13. 14 low. 15 high, which is correct. It should be low, low, low. So that's good. Band 2, so 13 low. 14 high, correct. 15 high, correct. 16, 17, 18 all land 3 megahertz. So 13 high, yes. 14 high, yes. 15 high, yes. So 16, 17, 18 all low. That one's correct. So 4 megahertz. Low, 13, 14 low, 15 low, 16 high, 17, 18 both low. That was correct. And 5. So 13 is high. That's correct. 14 low, 15 low, 16 high, correct. 17, 18 both low. That one's okay. 6, yeah, that's right. Try not to short these pins out, it's a bit nerve-wracking. So 13, 14, 15, 16 all low. 17 should be high, and it is. 18 low, so that was okay. 7. So you've got pin 13 high, which is correct. Low 14, low 15, low 16, high 17, low 18, so that was correct. Next one, which is 8 megs, low, high, that's correct, low, low, high, 17, low, so that was correct. Band 9, I'm going to carry on through these, you get the gist of it, but we'll see if we can find one wrong. If we do, I'll switch back on. I cannot shift this this fault at the moment. That it's basically still, when you get to 16 and 17 megahertz, it's jumping sort of like 250 hertz on the display, and then it after a short period of only a matter of like 5-10 seconds, it reverts back to the normal display. During that period, it is definitely not on the correct frequency, so I've been speaking via email to Greg from Hamandshortwaveradio channel. Again, I'll put another link to his great little site, his great little channel anyway, so you can have a look through some of his videos. But he's really been helpful, been giving me some hints and tips, his ideas of what it might be. But basically what it boils down to is it sounds like the PLL's not locking properly. It is locking eventually, but not initially. And it appears to be only in one VFO range, which is VFO 3. So what I'm doing today, I'm going to go through the PLL circuit, trace it back through to VFO 3, VCO 3, which is one of these in here. I'm going to look at the capacitors, the transistors and the diodes in that circuit. The other thing I've got to try, and I've only got it really because they were pretty cheap, was another one of these divider chips down here that sends a signal into the PLL. I have read on the net that these have been faulty in the past, so for the sake of a couple quid, it's worth trying. So I'm going to be doing that one probably first. I'm going to put I'm going to solder a socket in there, so as we can, in the future, if need be, swap it back out again. Hopefully that will never be needed, but you know, it's easier than soldering these chips to the board as well. You're likely to heat damage them, so at least you can't heat damage that if you solder that in. So that's the plan. So without further ado, I'm going to get the board back out again. So bear with me and join me again when it's out. Okay, the board is out. So what I've done to start with, I've gone through, let's get something to point with, gone through this row of diodes here, just down through here. I haven't taken them out of circuit, I've tested them in circuit, but they are all shown as diodes. If one was shown as something else, then I might have thought it was worth pulling them out. I've also been through these diodes, and I've been through all these diodes on the component tester, and they're all shown as diodes, which is good news. Now basically this is the path it's taking really. It's going through these diodes from the band switch, and then on the top of the board it's coming through this resistor network as well. So this is these are a row of 1 mega ohm resistors to earth, or to the negative side. So basically I've tested with my multimeter, my bench meter, if I can untangle everything. So just on resistance check on the ohm scale, and I am getting pretty much 1 mega ohm on every one of those, so that is okay. Another component ticked off was good. So really, as you can see, the next component in line is this IC here, MC14504B, which I believe converts converts the signal to something that the PLL chip can read. This is then the logic, and we have determined that the logic is okay on this chip. As I say, for the sake of a couple quid, it's worth swapping that out and sticking it in a socket. Really, there's nothing else from there through to check. This is the next in line. The PLL is obsolete, unobtainable. I will go through with my ESR meter and just check a couple of these capacitors underneath before I start moving up into the VCO territory. So this is the next stage. I'm going to get that one out. As I say, I'm going to solder in that one and then pop the new chip back in there. As I say, while I've got the board out, I'm going to check the components in here. There's a massive amount of wax in here. Unfortunately, I'm going to need to dig some of that out. I don't really want to heat it because it'll just run everywhere and it'll start coming out under the board. I have got some old wax candles, some beeswax candles, so I'll be using some shavings from that to refill this afterwards. I also need to do a final adjust of the VCO transformers, little coils, when it all goes back together. So that's the next stage. I will also, while I'm at it, go right the way through the back of the board in great detail, just to see if I can find anything, any bad solder joints in that vicinity really. So anyway, wish me luck. I'm going to crack on and do that now. Okay, so I've just gone through and reflowed those with solder. So I'm just going to go in now and desolder these. Let's see if that's moving. Hopefully they haven't stuck it down with glue as well. No, there we go. Just going to shut that up a minute. I'm just going to get in with my magnifier a second. Bear with me. I'm just going to make sure these pins are all freed. Well, there we are. That's the chip out of the board. So as I say, I'm going to pop the socket back in there. As you can see, I need to solder these back in. Then it's just a case of pushing the new chip back in the socket. Much easier than trying to put hot solder onto a nice new chip. So let's get this one soldered back in. Shouldn't need any. Actually, no, I'm going to need to change my soldering iron tip. Actually, still got the chisel tip on, so I'm going to swap to my pointed tip a minute to do this. Okay, back with me now. I've got my fine point on, so I'm just going to go in and solder a couple of these up first, just opposite corners. Bit of a tin first. Use that one for a while. Yeah, that's the holder in place. It's just a case now of just going through and soldering the rest of the terminals on. So I won't bore you with that. Join me when it's finished. Okay, well I've cleaned off the board with my flux cleaner, so it's done. Just giving it a bit of squirt of an IPA to remove the flux cleaner off the board as well. So I've had a good look under the magnifying glass, and that is all good now. Where are we? Yeah, just down through here, look. So they're all nicely soldered. So it's just a case of popping our chip back in. Well, the new chip, that is. So bearing in mind the cutout, it's got to be facing that way. The thing with these chips is they never line up with the holes first hit. You usually got to give them a little bit of a tweak. Just give them a little bit of an ease in on hard surface first. Come on, there she goes. No, not quite. No, just a little bit more. All I'm doing is just using the edge of my cutting board here, look. Just putting a little tiny bit of pressure on, popping it over, doing the same on the other side, just to bend them fractionally in. That side needs a bit more. If you go over, it's a bit of a pain, but there we go. I think we're not quite. There we go, just a gentle rocking forward and back, and there's our new chip. Okay, so far we've worked back through this way, through the diodes. I've checked the resistor. We now know that this one is new, so fingers crossed, that shouldn't be a problem. It's the same chip, MC14504B CP 14504B CP. So they are exactly the same chips. So where next? Well, we know the logic's okay on the PLL chip. So really now we need to start looking up here at this VCO. And luckily I've managed to get, can't really see what I'm doing here, can you? I've managed to get a better copy of the service manual. And that has got component layouts. It's also got some voltages as well. But one thing it has got, which is going to be really handy, if you can see that, I've zoomed in a bit there, look. But this is the underside of the VCOs. The one I'm going to be looking at is this one here, VCO 3. Let's get you in a little bit closer. Hope there's not too much glare from the light. Yeah, so this is the one I'm going to be looking at, VCO 3. So I've got a transistor in there, Q9, which I'm going to look at, and I've got an electrolytic capacitor there. So I'm going to take both of those out of circuit and have a look. There's also a diode here, D18. So really that's the three sort of common failures. Of course it could be a resistor, but as you can see they're really packed in here in a very tight area. So I'm going to unsolder them from the back of the board. So basically it's round that way. and I've got to desolder these 3 here. You can't see, I've gone the wrong way again. Can you see me now? Nope. Let's pop that up a little bit. So yeah, you can see the 4 VCOs here. Look, it says VCO, I think that's 4321. Look, which is that? Q 10, 11, 9, 8. Yeah, so Q9, which is this transistor here, is VCO3. So that's coming out first. I'll put that on the component tester and see what we got. Bear with me. Okay, here we are in the VCO. So you'll see I've dug the wax away and I've desoldered Q9 from underneath. There he is. So you probably won't focus on that, but the use of the same thermistors. They use the same transistor throughout this set. There's, I think, something like 70 odd of these in here, and it's a 2SC945, and it's Q rated, and the Q is the gain of it. I've tried to find some Qs, but I can't. I can get them from Japan in about 3-4 weeks, or China, but none in the UK. So I've managed to get some C945Ps, which are slightly higher gain, but they're not massively different. So what I want to do now is pop this one on my component tester and see what it's reading. Let's put that out of the way. Zoom back out a bit. Now they should have an HFE, I think somewhere around about 170 to 200, because Greg did think that possibly the VCO was getting sluggish, and I mean there's not a lot of things that could cause that really, I don't suppose, apart from transistors. So yeah, we've got an HFE of 245 on that. I don't know if you can see that, but basically NPN bijunction transistor, HFE 245, zero leakage, which it should be. So you know, I'm happy that that one is okay. So next up is the capacitor there. So I'm going to pop this one out next and we'll have a look at that one. Okay, the capacitor is out, the electrolytic. As I say, I'm only really concerned with this particular VCO unless something does show up amiss, and then it might mean that I need to change the parts in the other ones. So let's just hook this one up to the ESR meter. So this is a 47 microfarad at 10 volt. Let's pop that on. Let's see what it comes up with. Okay, so it's saying 53 microfarads. 47 to 53. That's not a million miles out really, is it? I will put a new one in there anyway, because it's pointless putting an old capacitor back in really, unless you're trying to preserve the look of it. We're not really worried in this area. But I was talking about doing a recap on this one anyway, so got to start somewhere, I suppose. So yeah, I'll pop a new one in there. Say it's pretty much there. I don't think these are extremely accurate, although I suppose it does need to be accurate in this area. Okay, that's back in now. I put the original transistor back in, but I've got a new Nichicon 105 degree capacitor in there. It's roughly the same value. It's around about 52 microfarads, but ESR is lower. It's only 0.5 on this one, and the other one was 1.16. So as I say, I might look at just changing these while I'm in here, to be fair. What I don't want to do is mess it up in any way, so that shouldn't be an issue. So as I say, I'm going to pop these out as well and change them for the Nichicons. No, I don't think there's nothing wrong with these Auna ones. Certainly even the ones that took out the power supply were measuring fine still, so probably a bit of life left in them yet. But as I say, it is a set from the early 80s, so at some stage they will come to the end of their life, and then it'll all have to come apart again. So it's a bit of preventative maintenance while I'm in here, really, I suppose. But, anyway, I'm going to get on next, and somehow in amongst all this goop there is a diode. So I'm going to find that one and pull it out and have a look at that and check it against the spec sheet. Not sure where that is yet. I'm going to find it underneath the board using the schematic. Okay, I'm just powering this up after the repairs I've done so far. Be interesting to see if we have made any difference. Still got noise, one good thing. Just line the band switch up. Okay. No different. Well, I'm going to need to do a VCO alignment on this one again, because I have obviously altered a few components, so let's try that a minute. Okay, well, I've just gone back through the alignment. Obviously altering some of the components in the VCO has knocked the alignment out slightly, but I've brought it all back in again now, but still got this same issue. If I rotate the dial all the way, start from 0, get up to 16, it jumps up to 17,617 momentarily. Doesn't last for long, mind you, but annoying nonetheless. 15, 16, yeah, 17,615,616. Yeah, unusual. Really not sure what that's all about now. As I say, done the VCO. That's all been upgraded, aligned. Yeah, it's a real strange one, this. The only other way is to work back through the other side of the loop. and look at the other ICs in the circuit. Yeah, very strange. Anyway, yeah, it continues.